Let's understand indices and surds in this video. Have you ever squared a number or taken a square root in class and wondered why it matters? Today we will see how powers and roots appear in daily problems and in exam maths in a simple way. First, what are indices or exponents? An index tells how many times a base is multiplied by itself. For example, 2 to the power 4 means 2 times 2 times 2 times 2. Here 2 is the base and 4 is the index. And index is another name for exponent or power. In algebra, we meet constants and variables, and both can have indices. Index notation is a short way to write repeated multiplication. For example, a to the power m means a multiplied by itself m times. Now, some useful laws of indices that make simplification easy. Zero index rule says any non-zero base to the power 0 equals 1. For example, 5 to the power 0 is 1. Negative index rule says a to the power negative p equals 1 divided by a to the power p. For example, 5 to the power negative 1 is 1 divided by 5. Product of same base. A to the power p times a to the power q equals a to the power p plus q. So, add the exponents. Quotient of same base a to the power p divided by a to the power q equals a to the power p minus q. So, subtract the exponents. Power of a power. The quantity a to the power p raised to the power q equals a to the power p times q. So multiply the exponents. Same index, different bases product. A to the power p times b to the power p equals the product ab to the power p. Same index, different bases, quotient. A to the power p divided by b to the power p equals the quantity a divided by b to the power p. Fractional index links to roots. A to the power p divided by q equals the qth root of a to the power p or the qth root of a all raised to p. Let us try some solved questions to make this clear. Question number 1 asks, multiply x to the power 4, y to the power 3, z to the power 2 and xy to the power 5, z to the power negative 1. Write the factors together. X to the power 4 times x to the power 1 times y to the power 3 times y to the power 5 times z to the power 2 times z to the power negative 1. Now add exponents for same basis. X to the power 4 plus 1 is x to the power 5. Y to the power 3 plus 5 is y to the power 8. Z to the power 2 plus negative 1 is z to the power 1. So result is x to the power 5, y to the power 8, z. Question number 2 asks, simplify a to the power 3, b to the power 2 divided by a to the power 2, b to the power 4. Subtract exponents for each base. A to the power 3 minus 2 is a to the power 1. B to the power 2 minus 4 is b to the power negative 2. So we get a b to the power negative 2. Rewrite with positive exponent. B to the power negative 2 means 1 divided by b squared. So overall result is a divided by b squared. Question number 3 asks, find the value of 27 to the power 2 divided by 3. Write as the cube root squared. 27 to the power 1 divided by 3 is 3. Then squared gives 9. So 27 to the power 2 divided by 3 equals 9. Next, surds are root expressions that are irrational, like square root of 2, square root of 3 and square root of 5. These numbers do not end or repeat. So we keep them in root form for exact answers, not decimals. Types of surds include simple surds like square root 2, similar surds that share the same root part, mixed surds that multiply a rational number with the root, and compound or binomial surds that add or subtract roots. Rules for surds. Product under root means square root of a times b equals square root of a times square root of b for non-negative a and b. Example, square root of 18 equals square root of 9 times 2 equals 3 times square root of 2. Quotient under root says square root of a divided by b equals square root of a divided by square root of b when b is positive. To rationalize a simple denominator, multiply numerator and denominator by the same root. For example, 5 divided by square root 7 becomes 5 times square root 7 divided by 7. Like surds add by combining coefficients, for example, square root x plus 2 times square root x equals 3 times square root x. To rationalize a binomial denominator, use the conjugate and multiply top and bottom by it. This removes the root terms in the denominator. Now a few combined examples quickly. Example 1. Evaluate 16 to the power 3 divided by 2 plus 16 to the power negative 3 divided by 2. Start with 16 to the power 1 divided by 2, which is 4. Then 4 cube is 64 and its reciprocal is 1 divided by 64. So sum is 64 plus 1 divided by 64, which equals 4097 divided by 64. Example 2. If the quantity 1 divided by 5 to the power 3a equals 0.008, note 0.008 equals 1 divided by 125, which is 1 divided by 5 to the power 3. So 3a equals 3 and a equals 1. Therefore, 0.25 to the power a equals 0.25. Example 3. The conjugate of 5 root 3 plus root 2 is 5 root 3 minus root 2. Example 4. Rationalize 1 divided by 8 root 11 minus 7 root 5 by multiplying numerator and denominator by 8 root 11 plus 7 root 5. Compute squares to get denominator 704 minus 245 equals 459. So result is 8 root 11 plus 7 root 5 divided by 459. Example 5 square root 7 times square root 2 equals square root 14. And example 6 square root 10 divided by square root 5 equals square root 2. While example 7 square root x plus 2 times square root x equals 3 times square root x. So what do we learn from this? We learn that indices give powerful short rules to combine powers, and surds let us work with exact root values without decimals. Let us quickly remember. Index rules are add, subtract, multiply the powers where needed. Fractional indices mean roots, and surd rules help simplify and rationalize roots. Keep practicing small steps and use these rules like tools on a blackboard. Thank you for listening. Stay curious and do explore more worked examples on EduRev to build confidence gently and at your own pace.